Algebra 2, Chapter 1, Section 4, Equivalent Equations. Two equations are equivalent if and only if they have exactly the same solutions. So what this means is they must have the same number of solutions as well as the same solution. For instance, this equation, x times x equals 3 times x, and x equals 3 are not equivalent equations. Why? Because x equals 0 is a solution to the first equation. 0 times 0 is equal to 3 times 0. And x is 3 is a solution. 3 times 3 is equal to 3 times 3. Whereas this equation has one solution, x is 3. Therefore, they are not equivalent. So operations that always result in equivalent equations allow us to transform one equation into another equivalent equation without having to prove the equivalence. So which operations can we do to an equation and maintain equivalence? If we add or subtract the same number on both sides, we will always have equivalent equations. For instance, if we have x plus 7 equals 3, we can subtract 7 from both sides of this equation and get an equivalent equation. Multiplying or dividing both sides of an equation by the same non-zero number also results in an equivalent equation. For instance, if we have 3x equals 7, we can divide both sides of the equation by 3. And that is an equivalent equation. However, what we cannot do is multiply or divide by a number which might be 0. In fact, we saw an example of this here. Here we have x equals 3, and this equation on the left is the same as the equation on the right, but multiplied by x on both sides. However, this is not an equivalent operation because x might be 0. And in fact, 0 is a solution to the equation on the left, but not on the right, as we showed previously. So whenever we divide or multiply by a variable, we must be able to show that it's not 0, or somehow treat the possibility of it being 0 as special. Otherwise, we do not result in an equivalent equation. And a third thing we can always do is replace any expression on either side by an equivalent expression. For instance, if I write x equals 7 squared, we can write x equals 7 times 7, because 7 squared is equivalent to 7 times 7. Or we could write 1/2 x equals 3, and we could write an equivalent equation. Here I'm going to go ahead and use this triple bar. X over 2 equals 3. And that's because 1/2 times x is the same as x divided by 2. Those are equivalent. And that's because these expressions are equivalent. This expression is equivalent to this expression. So we could freely substitute those in and keep the equation itself, here's the equation, equivalent. Why do we care about equivalent equations in algebra? Because they are a tool that we use to solve equations. Remember, solving is finding values of the variables that make the equation true. So let's look at some examples. Let's solve the equation 3x minus 10 equals 20. So the strategy that we will use to solve equations, generally speaking, is isolating the variable. That means we need to get the variable all by itself on one of the sides of the equations using equivalent operations to create a sequence of equivalent equations, giving us a solution. So the first step would be to add 10. That gets the 10 away from the x, so our x is being isolated all by itself. If we add 10 to both sides, we have an equivalent equation. Okay, and we could even keep track of y if we want to. Add both sides. Okay, now we can do some of the arithmetic. Negative 10 plus 10 is 0. 20 plus 10 is 30. We could just write simplify or combining terms. We only really need to write these things down if you want to show me your thought process, so I give you partial credit, or if you are told to show why they are equivalent, which is basically a way of asking for a proof. This is a very informal proof. Now, we need to continue to isolate the x. We may divide the equation by 3, because 3 is not 0. So we divide both sides of the equation by 3. Why do I use this long bar? Because I need to divide the entire part of the equation by 3. Divide both sides. This is why we can do this. And 3 divided by 3 is 1. 30 divided by 3 is 10. Just write combine. Or maybe we'll write, let's erase that. Maybe we'll just write arithmetic. Right, we're just doing arithmetic here. X is 10 is our solution. So we can go ahead and mark that as our solution. Now, let's work another example. That's not a very good looking 2. Let's erase that. 2 times the quantity x plus 3 equals 50. Again, we need to isolate our x. This time we need to divide first because the multiplication happens last. So in general, we're going to be undoing, if that's English, the operations. So you need to think about which operation would happen last in terms of this number and start there. Here we have x plus 3, which would happen first if we were evaluating, if we had a value for x. But it happened. We want to undo in order to get x isolated. So the first thing we need to undo is this multiplication. To undo the multiplication, we divide. Divide both sides by 2. Now I'm going to cheat a little now and write fewer steps. But I'm not going to write the reasoning down this time. 2 divided by 2 is 1. 50 divided by 2 is 25. Now subtracting 3 from both sides, I get x is 22. And on your homework, when it says solve, you may skip as many steps as you're comfortable with, but do not skip so many that you make mistakes. And show me your steps so I can give you partial credit. Remember, show your work. Always. Now, what if the problem didn't just say solve the equation, but it says and check? To check your result, take your solution, evaluate the equation. The original equation was 2x plus 3 is 50, and show that you have a true equation, which would make it a solution. 22 goes in where we have x. 22 plus 3 is 25. 2 times 25 is 50. 50 equals 50. So it checks. So we've learned about equivalent expressions in 1.3. Now we have equivalent equations. What's the difference? Well, remember equivalent expressions, which you need to memorize these definitions. Equivalent expressions have the same value for all or every value of the variables. Sorry, my handwriting is a little bit rough here. But that's what an equivalent expression is. An equivalent equation has, so each equation has exactly, every time you see exactly in math, it's important, exactly the same solutions. Okay, which also means it has exactly the same number of solutions, which we saw the example earlier where we had 2 solutions for one equation and 1 for the other. So 2x plus 5 is 13 and 2x equals 8. Is that an equivalent expression or an equivalent equation? Well, the equals is our first hint that this is equations. The second hint is that 2x plus 5 is not the same as 2x for all values of the variables. These are equivalent equations. And we can use this triple bar for equivalence. And with equations, you might find it even more visually identifiable to use this double barred arrow, which represents if and only if, or equivalence. So it's this thick double arrow. Two times x over 3 and 2x over 3, these are equivalent expressions. There's no equals. Equations, this is expressions.